Okay, so we have a block, a 5 kilogram block being released from point A, so that implies that it starts from rest. So V initial here is 0. It slides down the hill and makes an elastic, elastic, what does that mean? Two things are conserved. Momentum, which is always conserved in a collision, at least in the physics homework set. In real life, that's not true. So momentum is conserved, and if the problem says elastic, what's the second thing that's conserved? Kinetic energy. All right, so this block comes down, goes do, comes down the hill, bam, hits M2, and then the question says calculate the maximum height to which M1 rises after the collision. So what's M1 going to do after it collides with M2? It's going to go back up the hill, right? So after the collision, M1 is going to go back up to a certain height, to some height here. And the question wants us to figure out how high does it rise after the collision, after it bounces back to the left. Okay? So I wrote down the steps to solving the problem. The first thing you want to do, so step 1, find the velocity of M1 immediately before the collision. So when M1 is right here, when M1 is right there, what's its velocity? How do we go about solving step 1? Conservation of energy. Okay, so our 0 point's going to be down here. Make this the 0 point. So what type of energy does M1 start with up there? Potential of gravity. And then that potential of gravity gets converted to kinetic. Completely or not completely? Completely, because they tell us that the track is frictionless. There's no friction on the track, so therefore we know that potential of gravity initial is going to equal kinetic final for M1. We're applying this to M1. All right, so potential of gravity, mgh. Kinetic energy is 1/2 mv squared. So V is square root 2gh. 2 times 9.8, and then h is right here, 5 meters. So the velocity of M1 right before the collision is 9.8995. Don't round this because you're going to plug this in a moment. Okay? So we now have V1 initial right before the collision. V1 initial before the collision, 9.8995 meter per second. Okay, so I'm going to erase this. Okay, step 2. Step 2, find the velocity of M1 immediately after the collision. Okay, now here's the thing, guys. We have 2 unknowns here. We have 2 unknowns. What's V2 initial? 0. Object M2 is just sitting there before the collision. What are the 2 unknowns for this problem? The 2 unknowns are going to be V1 final. We don't know V1 final, and we don't know V2 final. Guys, if you have 2 unknowns, how many equations do you need? 2. So the 2 equations that you're going to use to solve the problem, conservation momentum, M1 V1 initial plus M2 V2 initial equals M1 V1 final plus M2 V2 final. What's the initial velocity for M2? 0, so we can just cross this out. That goes away. Okay, now, the second equation that you're going to use, it's actually a derived equation which comes from conservation of momentum with conservation of kinetic energy. Because what would conservation of kinetic energy look like? Conservation of kinetic energy would be 1/2 m1 v1 initial squared plus 1/2 m2 v2 initial squared, right? Total kinetic energy before equals total kinetic energy afterwards. But guys, you do not want to substitute these two equations together. Because why? The velocities are squared. That would be miserable, okay? So there's this third equation. There's this third equation that comes from combining conservation of momentum with conservation of kinetic energy, and that equation is V1 initial plus V1 final equals V2 initial plus V2 final, and we're going to substitute these two equations together. All right, so again, what's V2 initial before the collision? 0. So now I'm going to take equation 2, solve it for V2 final. V2 final is V1 initial plus V1 final. Okay, so take this and plug it in there. It's just, all this is substitution. So substituting that into equation 1, m1 v1 initial equals m1 v1 final plus m2 v1 initial plus v1 final. You got to distribute this. Elastic problems, they're a pain in the butt. Elastic is a pain in the butt because you got to substitute. Okay, so this is going to give m1 v1 initial equals m1 v1 final plus, so distributing that is m2 v1 initial plus m2 v1 final. What's the only thing missing in this equation? v1 final. Now guys, I'm trusting that you can solve this equation for v1 final. The only thing missing in there is v1 final. When you punch the numbers in, you end up getting negative 3.2998 meter per second. Why does it come out negative? Because what is the fact that it comes out negative? So to the right is plus, to the left is minus. The fact that v1 final is negative tells us that m1 bounces back to the left. So m1 is going to go boom, and it's going to head back up the hill. So the third step and last step is find how high m1 goes vertically after the collision. So how do you do step 3 here? Conservation of energy, which is fine to use because it's not the collision, right? Actually, you could use conservation of energy in the collision because it's elastic, but anyway, we have the velocity of m1 after the collision. So what type of energy does this have after the collision? Kinetic, and then the kinetic goes to potential, right? And we're looking for that h. So you go like this. Step 3, you go kinetic initial equals potential of gravity final. That's 1/2 mv squared equals mgh. The m's cancel, and now we can solve for h. So h is v squared over 2g, so that's negative 3.2998 meter per second squared, so the negative goes away. 2 times 9.8, and this gives an h of 0.556 meters. That's the final answer. Oops. 0.556 meters. Any questions?